You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this edition of Seen and Solved presented by Hubbard-Hall. I'm Tim Pennington, editor of finishingandcoating.com. And today we're going to be speaking with Mark Miller, who is in sales and technical services at Torch Surface Technologies, which is a division of Hubbard-Hall. Mark, welcome and thanks for joining us.
Yeah, well, thank you, Tim. Thanks for the invite.
Great. Let's start off a little bit. Give everybody a little bit of your background and all the products and services that Torch offers to the finishing industry and others. Why don't you go ahead and give us a little background on that?
Yeah, so I've been with Torch Surface Technologies for about 14 years, a little over 14 years now. And Torch specializes primarily in conversion coatings, like zinc phosphates, manganese phosphates, iron phosphates, the new green technologies like zirconium technologies, cleaners. We're kind of a mixed bag, but our core really is conversion coatings.
Right. That's, it seems like that's grown a lot over the last, I've been in the industry for just over a decade. It seems like I hear a lot more talk about that, especially, in aerospace and a lot of other technologies that use the conversion coatings.
Yeah, and one thing that's unique about Torch is we're very specialized. When it comes to zinc phosphates, there's a lot of competitors out there that deal with zinc phosphates, but we take it and narrow that right down to specific standards for the customer. We get involved with pre-paint applications for military. We get involved in rubber to metal bonding, where the coating microstructure, crystal size is. You've got to be, very specific on the size and because it really leads to the performance that the customer is looking for. So, we're really good at that. Not just a blue suit company. We do offer really tailored products to whatever the customer is looking for.
Great. Yeah. And you guys, how long has Torch been around then?
It's about a 50-year-old company. Yeah.
Okay.
Been around, been in Detroit the whole time, or we're outside the city limits now, but yeah, it's a Michigan company.
Yeah. I'll plead down to this. Conversion coatings, were they around 50 years ago, or is that something you all just evolved into?
No. Yeah. Zinc phosphates, manganese phosphates. Granted, there are a lot more greener technologies today than ever before. But yeah, definitely a lot of these coatings, manganese has been around for a long time, back in the, World War I, when they were coating, M1 carbines and stuff like that, World War II. So yeah, the technologies have been there. It's just, they've really evolved over the years.
Gotcha. Today, we're going to talk about closed loop systems. And first of all, give us a background. What is closed loop according to your definition? I know some people have different definitions of it, but what is your definition of closed loop system? What is it, and what's the advantages of that?
Yeah, so a closed loop system essentially is a chemical process that generates zero waste to drain, and essentially, so no part of that process. So let's say you've got a 5-stage system, and really it's managing the rinse water that comes off of those systems. And in some applications, we have found, we've done, worked with many customers to create closed loop systems, and we can manage that waste stream differently instead of having it go to drain, which eliminates a lot of headache for the customer. So, it's moving water, rinse water, upstream. So specifically, let's say a customer has a 5-stage process. Cleaner tank number 1 would be obviously a cleaner. Then you would have a rinse after that. And anytime, tank number 1 would, deplete from evaporation or drag over or something like that, we would refill tank 1 with number 2. So any water that we would be putting into that system would be going into those rinse tanks just to maintain, as clean rinses as we possibly can. And at the same time, not discharging anything to drain. So then there are some significant advantages with doing that.
Yeah. So is this different than a zero-discharge system?
Well, so no, a closed loop, zero-discharge, same thing. Yeah, essentially the same exact same. But in some applications, you can focus solely on one component of that process. If it's an area that is causing a lot of headache for, maybe an exceedance of zinc or phosphorus or something like that, maybe it is as simple as just focusing on closing off that particular area to go to drain, and we manage just that one area that is causing the headache. So it doesn't necessarily mean that it has to be a complete closed loop system. Maybe it is just one part, but ultimately, with the way the environmental constraints are going with municipalities, we try to really shut the whole thing right off that go to drain. Yeah.
Right. Yeah. So let me ask you that. Why would an operation consider going to a closed loop system? What are some of the benefits that they would see off of that?
Well, the biggest challenge that we're seeing right now is just, exceedances, environmental exceedances, going to drain. So municipalities, they're tightening up their constraints on what we can discharge down the drain. So where, you may have, been in compliance before, now you're not. That's really the big reason, is just helping the customer get back into compliance. So they're not being surcharged, fines. I mean, there's a whole lot of things that, the municipalities can put down on a customer, as far as, I've even seen that municipalities go as far as putting a cease and desist on the doors of a customer, saying they have to cease operation until they address the issue. So, at that point in time, you really have to figure out, does it make sense to go spend tens of thousands of dollars to put in a waste treatment system where you can treat water in-house before it goes to drain? That's a significant cost, and it takes a long time to get equipment. And maybe that's the long-term goal, but the short-term goal could definitely be looking at taking your current system and making it a closed loop zero discharge system.
Right. Yeah. It's funny. I guess when you do have a discharge permit, especially with the EPA, that opens up a lot more problems. I know right now we're seeing a lot of, or the EPA is going to be going out and doing these PFAS inspections, because they had these shops have permits. And so they're allowed to do that. So it opens up kind of and I've had a lot of shops say to me, boy, I really would like to not have to deal with all of this. And so, this could potentially be one of the solutions. But let me ask you, certainly, anytime people talk about going to a system, they look at, some upfront costs, but there are actually some cost savings to this, right? I mean, there is a cost savings to having a closed loop system.
Oh yeah, absolutely. The one big one they're going to notice right up front is the water savings. So, if your generally overflow rate is 3 to 5 gallons a minute, you're talking thousands of gallons a day in processed water just going to drain. We're only going to use a fraction of that. So there's going to be the savings is going to start just in the amount of water you use, and then just the reporting and all of the management of the system, of the waste. Right. You've got third-party testing, audits you have to do, all the requirements that the municipalities want you to test for. I mean, you're talking a lot of man hours. And with a closed loop system, all that goes away. You're not discharging anything, so you don't need to manage anything for them any longer. Now, there are things internally that we have to manage. I mean, we're not sending a lot of waste to drain, so we still have the waste stream. It's just how we manage that is different.
Right. Yeah. It's funny. I had someone tell me a while back that water is the most expensive chemical any operation will ever use. And it made me think about it, but yeah, I guess it certainly is. Right. I mean, it is a very expensive, certain parts of the country. I know out west, I just talked to a finisher in Phoenix who was asking about how they could, any ideas to conserve more water because it's so expensive. Plus, again, you've got the municipality on their backs to use less water. Right. And so they're trying to really alleviate those. Certainly with anything, any systems or things like that, there could be potential problems. But what are some potential issues that could come up with having a closed loop system?
So really, there's not really issues. I mean, it's just how we manage it that's different. So, like our rinse waters where we would normally let those go to drain, we have to start looking at pHs, total dissolved solids, conductivity, those kinds of things. So we can manage those rinses because the water, we're just not, our overflow rates are greatly diminished. So we still have those soils in there, but what is the longevity of that process or that particular tank? And those are, so it's not necessarily a downside. It's really just kind of learning what that new dump schedule is going to look like. Because eventually, like anything, I mean, we're introducing a lot of solids into the process, and eventually we're going to have to do something with them. And that's really the key is learning, tracking, testing those different tanks. And once you get your baseline, then we can go into a normal discharge schedule, whether that's quarterly, annually, semi-annually, or what, it's dependent. Every process is going to be a little bit different, Tim.
Right, exactly. Real quick, I mean, does it take a lot of to manage a closed loop system? You said you're not having to manage it as much as you had the discharge, but does it pretty much run itself once you get it up and running as well as it is, aside from just monitoring what's going on? Or
yeah, exactly. So the goal is to keep the rinses as clean as possible. We're using that rinse water upstream, so we're filling up the cleaner tanks, the iron phosphates or zirconium tanks or whatever our pretreatment is. And the goal is keeping once the customer understands how that water or that waste stream moves and how we manage it. It's super easy. It's super easy. And then we're going to have dump schedules that we're going to have to, manage as we run the process and throughout the year. But it's significantly cheaper to hire an outside party to come in and clean those tanks out than to deal with the city and all of the, reporting and discharge permits and all the requirements that are constantly changing and moving. And they're always setting a different standard, and the bar is constantly moving. This is so easy. And I will say, not every chemical process out there can you turn it into a closed loop zero discharge system. I mean, there's just some that are out there that are just, they're just the type of chemical process it's just not deemed necessary. I mean, there's just no way you can make it happen. But there are a lot of other, powder coating, for example, is a great process to consider. And those are majority of the processes that we convert over to closed loop are powder coating type systems.
Gotcha. Yeah. You mentioned chemical. Are there any special chemicals that are required to run a closed loop system, or is it pretty much what you all offer and people could use?
Yeah, nothing really changes. The chemistry that's on the line, it's really just managing the rinse waters in the system. Now, I will say, if let's say phosphates or phosphorus, right, is an issue, there are alternative type pretreatments that we can look at, like zirconium, nano technologies, different things like that we can put in there that are void of phosphates, that eliminate that right out of the waste stream. So it could be as simple as just maybe changing one product on the line and removing that sore spot. Or it could be multiple things. But in general, no, you shouldn't really have to, change anything on the line. It's just really how we manage the waste that's being generated. So
right, yeah. So are there any extra testing? That's one of the things. It's one of the things that I think a lot of people are probably shop owners asking themselves. Any special chemicals? Probably not. But what about any extra testing required with a system like this? How much do you have to do that? How much are they required to do? Besides, like I said, the regular dump schedules and things like that. But any other special testing?
No, not necessarily. I'd say up front, it might be a little bit cumbersome because we're trying to learn where, the soils and, kind of where that waste stream needs to go within the line. So we're testing probably a little bit more routine with like pHs and conductivity, things I've mentioned earlier. But no, there really isn't anything, those are really the core things is because if we have too high of a pH, we can, and that contamination or high pH or low pH gets down the line, it can kill a bath and cause some other issues. So those are really the critical things is just understanding, what the pHs are, what the conductivities are. But once we learn that, it becomes almost second nature, and you don't have to test as often, once we kind of get that baseline. So
gotcha. Probably not compared to if you had a discharge system. You'd be testing a lot more and doing a lot more of that.
Yeah, no, waste treatment system, there's a place for them, don't get me wrong, but this is so much simpler to just, control everything in-house. And, there is a cost, is to have that, the line cleaned out periodically, but it's significantly lower cost than it is to treat water in-house and to deal with all the headaches of that. So
right, yeah, and like I said, most times when I'm talking to shop owners and I ask them, who's in charge of wastewater, they look around the room to see who's the person in charge of these, and it's usually, not until they get a notice or something that they really do sit up and start taking things a little bit more serious about it, and that's often then they're scrambling to kind of bring the metal levels down and meet all the specifications, or they didn't know that new rules have been passed and everything. So you mentioned a bit earlier, you're seeing a lot of this in powder coating, right? So give us some examples of where you've seen shops have converting to this system, why they did it, and sort of how it worked out for them.
Yeah, so a specific customer has a multi-stage line, and they kept having zinc exceedances. And then it got so, they kept having so many zinc exceedances that the city was actually surcharging them for every month they had to pay a fine. And, after a while, man, I mean, that's just you can only absorb so much of that, especially in a process that, doesn't generate any value really, other than, just pulls out the metals and stuff like that. But so we got a call from our customer and said, what options do we have? And, fortunately for us, we've had enough experience with these closed loop systems that, we made some adjustments to their line after kind of showing them and looking at their line and walked them through that process. And they've been a zero loop system. They're running 2 shifts, high volume, high capacity. This isn't a small job shop. This is a huge manufacturer, and they're running 2 shifts, and they dump quarterly, the whole line, and it's saving them tens of thousands of dollars. So it couldn't have worked out any better for them. Another example would be, and we're running into more and more of this, Tim, with wand ash, what they call wand applicators, guys that are using heated wand washers and powder. So they're more like a batch applicator. Where we're working with customers to put a trench drain in their plant instead of having it go right down the drain. They're actually capping that off and putting a trench drain where we capture the solution. And then we have that pumped into some filters, pumped into a holding tank, and we're able to reuse that chemistry. So, so as basic as a batch application all the way up to a multi-stage application, you can consider looking at a closed loop zero discharge to drain process. We've got experience in both of those types of applications.
Right. Yeah. Like I said, a lot of finishers, when they get parts, they don't know what's really on these parts a lot of times. The rust inhibitors and other thing, the cutting fluid oils and things like that are just, when they come in their door and then they clean it and wipe it off, they're now assuming all responsibility for if they're going to send that to the municipality, right? I mean, everything they're washing off these parts, they have a responsibility to it, which, so like I said, to have a closed loop system kind of alleviates that problem to a certain extent.
Oh, absolutely. Yeah. I mean, all the headaches that can come in environmental, I mean, it's like the big buzzword out there. I mean, everybody wants to go green, and everybody, nothing hazardous and that. And so the bar is always changing. And, if you have the chance of looking at going closed loop and having a third party person treat that water for you, where you have manifests, everything's legal, it's the right way to do it. It's just such of a less headache internally in your own,
lesser of two evils a lot of times. Right.
You got to do something with the water. So either you're going to treat it or somebody else is going to. And if your process isn't big enough, then have it hauled off site. I mean, it makes all the sense. And there's just a significant cost savings in doing that.
Yeah. Final question. I mean, when you're called in, you guys go in and put eyeballs on the system, and you can really kind of look and see how long does it take to decide whether you can, first of all, whether you think they can, could you benefit from a closed loop system, and then, kind of designing and engineering it shouldn't take that long though, should it?
No, within just a few visits. I mean, there's some key things that we want to look at, like part configuration, what exactly we're washing off. I mean, if parts going in the line are just terribly oily, are there different things that we can do to manage that oil and remove that oil in real time, out of our cleaners? But no, it's pretty simple, formula on our end to come up with, there's certain characteristics in each of the stages that we look for. to see if this is a good fit for the customer. So
right, definitely worth a look. Definitely worth a look to see. Like I said, and I'm sure you can do some ROI for them, let them know what they be saving and what could potentially be saving and things like that. So it's definitely worth a look, I think, for these owners to kind of see if this is an option for them, and then how it could pay off for them in the long run. Definitely, including that getting rid of the headache. So yeah, definitely with that. Listen, Mark, appreciate it. Thank you for joining us. You taught me about closed loop. I appreciate that very much. But thanks for joining us today. I very much appreciate it.
Hey, thanks a lot, Tim. Appreciate it.
The Seen in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Allcast.